Because you can start now.
Okay, guys. Hello, everyone. I hope you guys are doing great. And I am audible, right? You guys are able to see my screen. Just a quick confirmation, guys, and then we can start. Okay, all right. Am I audible, guys? Okay, fine. So let us start, guys. Okay. So yesterday we were able to see what is the entire life cycle of the machine learning project, right? And when we went through a very amazing use case where we were able to discuss how we can identify the sleep disorder once we collect the entire data from the patients. Okay. Yeah, guys, congratulations. Yes, launch of Chandrayaan 3 is successful. So with this note, just let's begin our topic today. Okay. So we are getting one more success now. India is making really a good progress, and so is the AI. Okay. So guys, we were able to see a very amazing use case where we saw how the entire life cycle is getting created. We looked at the example that how right from the data generation from the smartwatch to how this data is getting uploaded into the app and how this data is utilized and how machine learning algorithm is performing. And we also saw how we can analyze the data set, how we can clean our data, what are transformations are required before we feed our data into the machine learning, and then how to perform the EDA, right? Exploratory data analysis. Like we looked at the different visualization, we saw different columns and their relationship all together. Then we were able to also see that how the columns are or features, which are called as features in machine learning terms, how they are interrelated to each other, right? And if there is a correlation, we also able to saw that how to plot this correlation plot. So we, in order to see that whether all the columns are required or not. And then we saw that once the data is clean, feature selection is done, then we were able to find the data into the split, like train and test. And then we were able to choose which algorithm to choose. Then we were not able, we will not stop at only one algorithm. We started with taking one algorithm, then we saw what is the feature importance. And according to that, we again built multiple models, like let's say in this case, logistic regression was also built, random forest was built. Also, we saw one more model, and we tried to find out this accuracy and whatever is giving us the highest accuracy and robust model. We thought that we'll go with this model, and then we'll finally implement it. Once we are ready with the model, then we will give it to the end user or so at the backend team, so they can integrate, create an API and make it that can be consumed by the end user. So that's how we saw everything, and hope you guys enjoyed that session. So today what we'll do is we'll start with one more code walk. My voice is low. Guys, are you able to hear me clearly or is it really low? Just give me confirmation, guys. Clear, right? Okay, we can go ahead then. What we'll do is agenda for today will be right. We will again go. I will make you guys a walkthrough through the code where we will be able to see that how we can solve one more amazing use case. And in this case, what we'll do is in this case we'll try to find out whether this currency or note which is there, bank note, it is real or not. So we'll start with this one. Then we'll try to understand what are the limitation. Okay, what are the limitation for the machine learning languages, why most of the machine learning language models are failing, and what could be the probable use case, how we should choose the machine learning in order to solve the business case. Okay, that's what we're planning to do. And then in the end, once we go through entire this code, then I will give you guys one task, and that task will be you guys have to come up with a machine learning model, where I will be giving you data of a particular bank. And in order to analyze whether these bank customers are going to churns mean what, whether they will leave the bank or not. That's the decision you have to take based on the machine learning model, right? So that end result will be, don't worry guys, I will open the data set and I will try to make you explain everything, and we'll make this material available for you. So you can go back, look at the code, and you try to implement the similar way that we implemented the model for these two projects. Okay. So, okay, let's get started then. First of all, we'll start again with the code walkthrough. Let me share the screen. Hope you guys are able to see the PDF file, right, guys? Just give me quick confirmation so we can go ahead. Then. All right. So let's start then, guys. So here we'll try to understand what is our use case first. So once we understand what is the use case, then we will be able to understand what is the end result that is expected from us. Okay. So first of all, try and understand what we are trying to do here. What we have to do is we have to decide whether this particular note, currency note is genuine or not genuine. So what kind of and what we'll do is we try to find out first, import the data. We try to clean the data. We try to visualize everything, and we'll apply the three models. One is logistic regression, k nearest neighbor, and one more model, guys. Okay. So let's try and understand that what exactly and what parameters we are trying to achieve this decision making. Okay. So let's imagine. Okay. First thing what we look at is length. Okay. What is the length of a banknote? Okay. In this case, so this entire length, right? We try to say what is the length of the banknote in millimeters. Then we will try to see how is the width, left side and the right side, right? This width, right? We'll try to look at the left side and right side of the width. Then once we are able to see the width, then we will be try to see if you guys can see their edge and the where the picture start. There is a small margin, right, on the bottom side, and similarly there will be similar margin on the upper side of the note, right? When before the picture starts and before the edge of the note, right? This difference. So we will also try to consider this difference, margin from the bottom side, margin from the above side, length of the note, okay, height of the note, left hand side and right hand side, this height of the note, and we will also try to understand what is the length in the diagonal. What do you mean by diagonal? I'll tell you. Just a minute. Let's say this is our note. So we'll try to also measure the diagonal distance. Okay. So we'll try to measure the diagonal distance. We try to measure the length. Okay. We'll also try to see the height from left side, also from the right side, and margin also, because even before the note starts and in between there is a picture, right? The picture starts, there is a slight margin, right? So margin from the upper side, and also there will be margin from the below side, this margin. So all these parameters we'll try to take into consideration, right? So all these 6 parameters we'll take into consideration, and then we will feed this data to the machine learning algorithm, and the machine algorithm will have to tell us whether this note is genuine, okay, genuine or no genuine, okay, no genuine note. Whether it is genuine or it's not genuine, whether it is real or fake note, right? Real or fake, genuine or not genuine. Okay, you can say this. Okay, clear, guys? What is our business case? Just give me some confirmation that what we are trying to solve here, so we can start with the code walkthrough. Anyone having any doubt or what is the use case? Once again, okay, guys. Let's try and understand again, okay, what I'm trying to tell you. Let's say if this is our note, right? And within that note also, after the edge, there will be picture, right? This most part is clear. Okay. So what we're trying to do is we are having these 6 parameters on the basis of which we can say that whether this particular note is real or fake. Okay. That's our problem. So what are the parameters? First parameter will be the length. Length in this way. Starting from, let's take different color. Starting from here to here. This length we are trying to measure. Okay. And then second parameter will be height. Okay. This left side height from here till here. What is the height? Okay. From right side, similarly there will be height from the right side So these all measures are this all measures will be given in form of the table, right? So first we saw what is the length, then we saw what is the height of the node, okay, from left hand side and from right hand side, because we need to measure the distance from both the ends, okay, from this end as well as this end. Then once we are able to see what is the height, then we'll see diagonally what is the distance, okay, diagonal distance or diagonal length. So what is the diagonal length, right, from one corner to another corner, okay, diagonal. So that will be also in millimeter, okay. That will be the fourth criteria, right? And then what we'll do is, like I told you, margin, right? Once the notes start and before the picture begin, there will be certain margin like this one, right? This margin, this part we will also take into consider. This will be the upper margin and this will be the lower margin. On the basis of that, we'll try to decide whether this note is genuine or not genuine. If you look at the picture again, I'll try to draw it here. So it will be more clear to you guys. So we are looking at this lane, height of, right? This is the height. Let's say this is from right side. There will be similarly height from the left side. And then there will be length of the note right from the beginning till the end. This will be called as length. Okay. Length. Then there will be diagonal distance. Right? Diagonal distance which will be coming here. And this is the margin, guys. Right? Before this picture starts and before the edge, the between distance, this distance from upper side of the node and also from the below side of the node. So these are the 6 parameters of which the data will be provided, and then our machine learning model will have to tell whether this is a real node or not real. That's it, guys. And just ping me, guys, that if you are clear with what we are trying to achieve, so we can move ahead and then directly start with the importing data and looking at the code. I need, guys, couple of confirmations before we can go ahead. So everyone is on the same page and everyone is trying to understand what we are trying to achieve then. I see only one yes, guys. Just couple of more yes, and then I will be sure that it is very clear that what we are trying to achieve. What are our features? On basis of what features we are trying to predict whether this node is clear, real or not real. Yeah, guys, couple of more years and then we can start. Or just put it in reverse way. If someone is not clear or something like that, then just say that you guys are not clear, so I can explain it one more time, then we can start. Let's put it in this way, that if someone is not able to get, or what exactly the concept is not able to get, just also mention that, so I can tell you which feature is not clear for you. So we can start, guys. Quickly, guys, without wasting our time, because we have a lot to discuss today. Just tell me if you guys are not able to understand what features we are looking and why are looking at feature, or any certain under ambiguity you guys are having. If you are facing an ambiguity, then just quickly, I will wait for 1 minute, guys. Just ping me quickly so I can take that point. Otherwise, we can go ahead then. So yeah, I am going to show you guys. I will make an entire code walkthrough, okay? And I will give you a different assignment to solve. Anything else, guys? Any doubt? Okay. No doubt, I have assumed that there is no doubt. Sir, algorithm are used quality controls in manufacturing. Yes, sir. Algorithm are also used for quality control purpose. We can do a similar thing in manufacturing also. Even I will tell you one amazing use case, that what could be a machine learning use case in case of the manufacturing. Let's say if we are having a manufacturing company which is using, there are multiple actually, but I will tell you one simple example. One example for machine learning side, and one example which is very popular from the deep learning side. Okay. Let's imagine that your company is producing certain things or producing some data. Okay. And you guys are let's say manufacturing the chipsets. Okay. This kind of chipsets you guys are manufacturing. Okay. And this entire purpose of this chipset is to generate the data. They are working as a sensors. Okay. They are working as sensors. On the basis of this sensor, we will try to collect the data and we'll try to analyze whether all my machines, whatever machines are implemented, whatever manufacturing work they are doing. Let's say they are creating one product, which will be, let's say, part engine. Let's say they are creating an engine of a car. Okay, car engine. In that process, what will happen? They will first start with the casting. Okay, then there will be certain other CNC machines will be there, and then there will be certain other operations performed. Then maybe they will create with the piston, right, burning chamber and all. Then they will assemble somewhere here, and once they assemble, they will try to test it. And at every point of time, they are trying to check, right? Now they are trying to check whether this functioning is happening correctly or not. So let's say they have implemented certain sensors for this purpose, and on the basis of the sensors, this sensor, we are trying to check the information, right? So once I have implemented sensor at each and every stage, okay, and this sensor is able to give me the data that what is happening, how many, what is the count, and how it is happening, everything, right? And this is the use case that we have to measure by using these sensors. We have to measure at each and every process of this, that how car engine is created, and I have to measure whether there is a correct job process is followed or job description is followed, and whether this is giving me a correct result or not. So for that purpose, I have created a custom made sensor, and which will be able to give me data. On the basis of the data, I will be able to understand. So how machine learning will happen in this case is, what will do, they will do whatever data which is given by this sensor. Okay, I will call them as a sensor. Let's denote them in the different colors so you guys will be able to understand. So these are the green sensors on top of each and every process, and the square boxes are the processes, right? So everywhere I am having the sensors for each and every steps. Let's say there are 5 to 7 steps, and we are trying to, what we are trying to achieve is, we are trying to create a car engine. Okay, here we are trying to create a car engine, right? Engine of the car. And this is a solely manufacturing process which is going through the multiple stages, right from the creating the CNC, using the CNC machine, taking the material, then making a piston on a combustion chamber and everything. I don't know much of the detail, but cylinders, there will be certain cylinders, because when I went for the internship during my post graduation, I went for a manufacturing company which was producing the car machines. Okay, which are producing the machines which are usually the engines for the double cylinder engine for the cars, very high end car. So at that time, I realized, I went to the floor shop and saw entire things and how end to end this process is working. And I also went through the assembly line. So on the basis of that, I'm trying to give you example. Okay, what they're doing. So these are the different stages, and at the end of this stage, they will create an engine, right? This is the engine. Then for that purpose, they have installed some sensors, whether they want to check that process is going correctly or not. And for that purpose, all the sensors are installed, and these are certain conditions which are installed in the center, and we need to change your screen. Guys, I'm trying to explain one example. Okay, so where we can apply in manufacturing, that's what I'm trying to give you. I hope you guys are trying to understand, follow me. So when this sensor are giving me data, so I can, on the basis of the machine learning, I can check whether these sensors are giving me a correct data or not. Okay, so once I collect the data from these sensors, okay, and I try to analyze whether these sensors are giving me a duplicate data, or what kind of range of data they are supposed to give me. Let's say every sensor is giving data somewhere between 0 to 10 or something, some sort of data, which I have already defined the range. Okay, so according to this range, I know that what will be my range of the data, what I am expecting from this sensor. So if you take this data from the sensor and you try to provide it to the machine learning algorithm, on the basis of that, what machine learning algorithm will do, we try to cluster the data in the different regions. Okay, and it will able to tell me which sensor, it will try to bifurcate that which sensor is not working properly. So this is real-time use case, guys, how it can be done in the manufacturing, and this will help us that whether my entire process is working correctly or not. Okay. And then there could be one more use case which was implemented in the company, which is brew company, where there is a shredding machine, right? This is the shredding machine, let's say, and every person has to pass this, manually pass some material And what usually used to happen is there used to happen the accidents. Whenever this person or workers, they're trying to put this material, leftover material for the this shredding machine. Sometimes they used to have an accident with their palms or hands, and their finger used to get cut, or they used to get injured. So for that purpose, what they did is they installed one camera here. Okay, they installed the camera, and this camera was able to give the feeds, real-time feeds from this machine and the workers which are working. Okay, and taking from that video, they created the image. On the basis of that image, they were able to draw a boundary. Okay, if let's say this is a shredder. Let's use different color, red color. This is a shredder, and this is where the shredder's line will start, and this is my palm. Let's say. Let's create a palm. So this is the hand of a person or any worker who's trying to push any material in this shredder, right? So there is a boundary. Until this boundary, you reach this boundary, they will not meet with any accident. But once their hand passes through this boundary, it is possibility that their hand may get stuck into the machine or can automatically get pulled in this machine, or they may face with the accident, or they may lose their hand. So there were several accidents happen, guys. For that purpose, what they decided that can we come up with some solution using the AI, right? Some solution with the AI. So what these guys did is they installed one camera. Using this camera, it was able to give us a live feed. And out of this live feed, we created this live feed into the different picture. And on the basis of this picture, we decided, okay, let's try to segment this picture. Okay, this is the position of the shredder whenever I receiving the images. And if this is a position and this is the end line, okay, this is a danger line. If I can reach to this danger line, it's okay. Beyond that, I may meet with the accident. So using the computer vision technique, they were able to identify, draw a line. And once the palm of the worker goes behind this line, it will create a trigger. It will create a trigger, and this trigger, in fact, will stop this machine, shredder machine, immediately. So that is a really amazing use case, guys, which was implemented in the brew company, okay, brew coffee making company, and this was successfully implemented, okay. And then after that, they got really amazing results that they seen the less accidents. They see there were almost no accidents happening, or that there were no incidents for the mishaps which were happening before because of this shredder machine. So that was also amazing use case how AI was able to solve this one, and that was entirely using the computer vision technique. So this is not the class to go in detail like what it exactly did, but this is a real-time implication how in manufacturing companies also there are many use cases for quality control purpose also, from which we will be able to implement the machine learning or a deep learning techniques also. Okay, so let's moving back to where we started. So I hope that everyone is clear that what we are trying to achieve. We are trying to see that whether this particular node information I am providing, whether it's real or fake, and how I am trying to decide is based on the certain lengths or measurements which are available with me. Measurements, 6 kind of measurements which is giving us the height, length, width, and the margins from above and below, and the diagonal length. That's the whole purpose what we are trying to achieve here. So without wasting time, let's go into the code. Okay, first thing what we usually do is let's before we even really begin this use case, guys, I would like to understand from you guys, if you are able to understand what is the use case, just quickly tell me, okay, what kind of task we are trying to perform. I told you machine learning will majorly performing 3 tasks, right? One will be regression, second will be classification, right? And third will be clustering, right? So just tell me out of this, what kind of problem you are trying to solve. Ma'am is saying, Ujula ma'am is saying, yeah, it's classification. Shanmugh Priya is saying regression, guys. Come on, few more votes and then we can understand whether it is a classification or regression problem. Come on, guys, quickly give me a response that you are able to understand what kind of task we are trying to perform here, whether it is a regression task, whether it's a classification task, whether we are trying to make a clustering over here. Mr. Anil is saying classification. Okay. Because we are fitting the value. No, no, no. We are not trying to fit value. We are getting value, but we are trying to decide whether it is real or fake. Regression. No, it's no. Regression, classification. Few more, guys. I think we are getting very weird responses. Not weird, we can say varied responses. People are not agreeing to anything, I think. Some of us are saying classification, some of us are saying clustering, some of us are saying it's a regression problem. Few more things, classification, regression. Satvik, you are saying regression. I don't know, but we'll try to understand. Okay, let's wait for a few more votes and then we try to understand whether it's a regression or a classification problem. Binary, Varsha is saying binary classification. Come on, guys, few more votes. So I think why I'm doing this exercise is, guys, because of your response, I will be able to understand whether your guys are trying to follow with this project or not. Because today, at end of the session, I will be giving you a assignment and where you have to predict a similar use case, okay, real-time use case, and then you should be able to solve it on your own. Once you are able to do this, then I can give you a degree that you are a machine learning engineer now. Come on, guys, few more votes and then we can understand this one. Use case classification. No other views, guys. Come on quickly. 1 minute, last 1 minute to give your vote. So then I will start explaining whether what kind of solution, what kind of problem we are trying to solve or what kind of task we are trying to solve here. Guys, do you want to become a data scientist or not? Then tell me quickly. End of this, if you are able to perform the project, whatever project I'm giving you, so you will really become a machine learning engineer. Trust me, and then you will be able to solve any use case using machine learning. Coding part is not difficult, guys. ChatGPT will write a code for you. You have to just understand the process and you can implement by looking at the code. Few more responses, guys. Just make it more exciting. So everyone is on the same page. What I'm trying to do is I'm trying to see if everyone on the same page and trying to follow this thing. Come on, guys. Just give me your opinion. We are trying to find out legal or not legal. Yes, we are trying to find out whether it is a real note or not real. Correct. Any other views, guys? Or we are good, we can start. Proceed to code. Let's try and understand few more things from the people. Come on, guys, give me quickly reply so I can understand you guys are on same page or not. So I can again start understanding the issue. Legal or not legal, binary classification, sir, yes. Any other views, guys? Whenever you're saying what kind of task you are trying to perform, also give me reasoning that why you think that this is the task because of this reason. Try to find the authenticity of a thing. Yes. So what do you think? What kind of task we are trying to find out? If we are trying to find out authenticity, then what kind of task it is? Whether it's a regression, classification, or clustering. What else, guys? Give me reasoning also why you're thinking that this is the task of regression or classification or vice versa. Classification and clustering. Yeah, I will come to that thing. I'll come to that thing, guys. Any other opinion, guys? Or what do you think? It is not even problem of the machine learning. It is entirely different. It's an NLP problem, or it is a deep learning problem, computer vision, because we are dealing with the authenticity of the data node. We are not going to fit the data into two sets. No, we are going to fit the data, but not in two sets. Real node or false. Yeah, we are going to check real node or not real, but what we are trying to achieve is we're trying to achieve the category, whether it is real or not real. We also can apply logistic regression. Yes, ma'am. We started about talking about the algorithm, but I am just asking you guys, okay, what kind of task is this? Whether it is a regression task, it's a deep learning. Yes, sir, possible. You can also do deep learning, but we are trying to look at machine learning algorithm now. So I will try to solve this problem using the machine learning, where this is classification problem, regression problem, or clustering problem. That's what we are trying to achieve here. And if we are able to understand, see, most of the times what happens is whenever there is a use case, people fail to understand how I am going to solve this use case. If you are not able to understand how you are going to solve this use case, then how you will apply what kind of algorithm I need to implement in order to achieve the end goal. That's the reason I am trying to focus more on this part, right? So usually people think that if I am a good coder, I am a good Python developer or R developer, I will be a successful data scientist. That's the hypothesis I'm trying to prove you guys wrong. Okay. People think that I am a good coder. If I am a very, very superstar in coding, then I will be able to perform any task. But this is not a situation. Otherwise, in all the data science and deep learning job description, they would have only written that you should be very good or expert champion in the programming language, then you can solve any number of cases or any type of use cases. But that's not the situation, guys. Why we are taking into consideration all the industry experience, or what kind of knowledge we are trying to implement, why looking at the logical reasoning, why we are looking at the different graphs, relationships, why we are looking at the different statistics, then if I have to only take care of the programming language and solve this issue, right? Or if I am dealing with only with the one kind of rules, one set of rules, logical reasoning, and that's it. Voice is clear or not clear, guys? Some Arvind is saying my voice is not clear. Is it clear, guys? Okay, very clear. Okay, guys. So I think enough of suspense. Let's start understanding what we are trying to achieve here. So like I told you guys, whenever we are trying to perform machine learning or try to solve the use case, at that time we'll see that what major tasks we are trying to perform out of this. We understand that what our use case is, that based on the provided data, based on these six type of columns, where we are trying to measure the distances majorly, right, in the millimeter. Let it be margin from above, margin from below, diagonal margin, or height, or the length of the node. Okay, all of them, what we're trying, even we are taking the numerical data, in the end what we are trying to find out is whether this node is real or fake, whether it is genuine or not genuine. So this kind of task may come under the classification. Okay, usually we try to solve this, because what we're trying to do here is we're trying to bifurcate whether this particular node is real or not real. Okay, so what I'm doing, trying to classify the things. I'm trying to classify the things. So that makes it a primarily classification algorithm. Once you understand primarily what I am to achieve, you can do a mixed hybrid approach also. Like we try to understood that I can apply the hybrid approach. Once I get the data, I can even make the small cluster out of big data, small clusters. And out of that clusters also, I can apply the different algorithm, regression classification algorithm. This is also possible, guys. That is a complex task, but try to understand from the basic point of view. From basic point of view, we're just trying to decide the two conditions, whether this node is real or fake. So this gives us two classes, real or fake, and we're trying to classify. That's why primarily it will be a classification algorithm. Clear, guys? Why it is a classification algorithm? You can use deep learning also. You can send this picture directly to a neural network. Okay, this kind of neural network will be there, and this neural network will be able to tell you whether this node is real or fake. That's also possible. But since this class, we are trying to understand that how we are going to solve this issue using at the different statistical values. That's why we are trying to understand that how we can achieve this. And for that purpose, we are considering this as a classification algorithm. Okay. I hope now this explanation is enough for everyone and everyone is on the same page. Considering that, we can look at the code round. Okay. Just quickly have a look at the code, then we can understand how these things is getting done. So first thing first, whenever we start with the codes, we try to import the libraries, because we require certain libraries in order to perform certain tasks, and all these tasks or functions are available in these libraries. Okay, in these libraries. So first, what we'll try to do is we'll try to import NumPy, then pandas, and then matplotlib and seaborn. Okay, then NumPy and pandas. If you guys remember, when we discussed the entire roadmap for the machine learning, or what are the important frameworks which are available for the machine learning, we discussed both of these libraries. These libraries is used for the different mathematical calculation, different mathematical and statistical calculations for the data. Okay, guys. For that purpose, we have a NumPy and pandas. NumPy and pandas comes in pre-built functions where we can use this function and we can perform the SQL-like operations. Like we can select particular row, we can sort them, we can replace some values. Okay, we can append some values in the end. Okay, we can append, we can group by, we can create a different group out of this table. Okay, there are a lot many operations which are possible with the data we can perform using these two operations within these two frameworks. One is NumPy and pandas, and these are also called as libraries in Python, right? So that's why we are trying to import NumPy and pandas and as NP and PD. Import NumPy as NP, import pandas as PD. Then next library, what will require, like I told you, whenever we are doing a data science job, once I am able to import a data and I have to clean the data, right? Perform cleaning. I have to perform cleaning, right? Once I am able to clean the data, next thing is to visualize the data, right? In form of the different graphs, right? Or it could be something like that. Or it could be this graph. Or we can look at the correlation matrix altogether with different features. Okay. So there will be 1, 2, 3, 4, 5 features. Against the similar features, we try to understand what is the correlation between this 0.9. This kind of values will be there. What kind of correlation exists between these? Correlation means nothing but it's a relationship between how once if there is a change in 1 unit of X, what will be the change in this similar change within the Y. So that's the simple thing is correlation, guys. Whether once if this moving towards positive direction, whether this is also moving in positive direction or negative, at least it's moving, it's okay. There's a correlation. If there is no change as per the X, there is no change in Y, then there is no correlation. This kind of things we are trying to identify using correlation matrix. So once we identify the correlation matrix, so that is again a part of the feature engineering. So for that purpose, in order to see different graphs, there is a libraries available. One popular library is matplotlib. So we're trying to import matplotlib as PLT, and then also seaborn, which is also built on top of the matplotlib for the advanced visualization. So we are trying to import it as an SNS, and this one is PLT. That's the only name we are trying to give to this libraries. So when we'll try to use different functions, so I can say PLT dot histogram or something like that. Whatever charts I am trying to use, for that purpose, I am giving them the acronyms. Okay, matplotlib. Every time if I try to write a matplotlib and then dot and then it will create a very complex structure. In order to make it very clean and structured data, okay, structured coding, I am trying to give them the acronyms, different acronyms. That's what NP, pandas. Okay, import NP, NumPy as NP, pandas as PD, then matplotlib is a PLT, and seaborn as SNS. So I'm trying to make it matplotlib inline so that all the time this particular package will be loaded, even in this particular session. Yes, enumeration, guys. So that's the first part. What I'm doing, load all the necessary packages which I require to perform the calculation on operations. So that is the first part we did here. Okay. Then second part will be loading the data, right? We need to load the data, whatever data is there, whatever use case we are to solve, we have to load the data, right? For that purpose, I am creating a data frame. This data frame is nothing but this kind of table, guys. Okay. This kind of table I am trying to create. For that purpose, I am giving a name df, which is just again a name, variable name. Okay. This is the name of the variable which I am giving. How to set path for loading the data. Okay, guys. What we have to do is when I am giving this command, so I want df is a name for my table, whatever table I am trying to import. then I can simply use this command pd. Pd means what? Pandas dot read CSV. And before giving this name, because name of this file is billets.txt, I can give path. Like let's say before this, I can say C in C drive, let's say Vikas. And out of that Vikas, where whatever the path where you're trying to store this one, or maybe it is coming directly from the let's say any website or somewhere else, you have to provide this path. But to provide the path directly download data from any website, there will be certain other ways how we can provide the path, and then followed by the name and .txt and separators. Guys. Yes, it will, ma'am, it will work for the Colab also. But for Colab, what happens is Colab has a certain way how we can import the data, right? How we can import the data in Colab is we have to mount this file on the Colab by using the Google Drive. By using the Google Drive, you can mount this data. It is called as mounting this data. You can download this CSV file or text file, whatever is available. You can take this file and you can upload this data to Google Colab, Google Drive. And from Google Drive, you can obviously you will make certain settings, and from there it will be made available on the Google Colab Drive for your profile. Obviously, when you log into Google Colab Drive, you will try to log in with your credential and all, and there will be a Google Drive. Your personal Google Drive will be attached to this Google Colab, and that's how. Guys, am I clear now? Is it clear, or still any issues in the voice? Please elaborate with example. Okay. So later on session, guys, I can give you example how we can do it. I am simultaneously in Colab. Okay, but you can just Google it. Okay, you can just Google it, because if I try to tell you right now, then maybe it will take some time to understand and tell you how to do this process. But you can just Google it out that how to upload this thing, because it will take some time. Okay, so we can go ahead and later on you can try. You can Google it how to upload it, mount it on the drive. CSV, guys, I will share. The entire material will be available in the LMS. Okay. By using this LMS, you can download file or check the files, and also whatever material we have discussed presentation, everything I am going to give it to you guys. Okay, don't worry about it. I already told Amar, and Amar will coordinate with the backend team, and he will make you available. CSV stands for, okay guys, CSV is comma separated file. CSV, your explanation is clear and everyone can understand. Thank you very much, Vijaya, for the confirmation. Okay, so what we are trying to say is, if you want to give path, you can give your personal drive path also, C drive, D drive, wherever you're trying to store the thing, and then you can import that using read CSV. Read CSV is not only one option. What is the full form of CSV, guys? CSV means comma separated file. Okay, whenever data is imported using this certain format, which is comma separated, let's say this true, it will be in this format. I will tell you, it will be a kind of Excel sheet only, or let's say comma separated value. Yes, correct. So it will be in Excel sheet, or let's say text file only, but the way how the data is separated from each other will be commas. There will be commas, or they can have also tab in between. So that will be called as TSV. Okay, these are certain formats using which they can store the data or bifurcate the columns from each other. So comma separated CSV, tab separated TSV, or we can have an Excel sheet also directly, or you can have a JSON file, JSONized file. It is one of the format, I guess, guys, where we try to save the data in key value pairs. Okay, it will be followed in curly braces. Then we'll give a key and a value. Key will be like is genuine. Okay, let's say key will be like is genuine. This will be the key, and in that key, in form of a list, all these values will be stored. Okay, followed by this kind of separation. Okay, that's how it will store the data, guys. So JSON format, any kind of format, whatever is feasible, we can do it. For that purpose, everyone will have their different functions available. All these functions are available, guys. You can go to these libraries and you can check the help, and according to the file format which you are trying to import, you can import this. But for the simplicity, right now we are taking, or I will be also providing you the data in the form of CSV or text format. So I am giving you this. Okay. try and understand that once I read this data using this command pd.read.csv, okay, so that means I have created this file. Sep means separated, guys. Sep means separated. How it is separated? I need to tell my machine, okay, whenever it's trying to read, what kind of separator is used in this file. So in this here it is used as a semicolon, right? It's a sign of semicolon. Maybe they are used separate as a colon or some other separators they are using to store the data or bifurcate from each other. So that kind of parameter also you can pass it. You try to analyze it the moment you say CSV, but if there rather than the usual CSV format, if you are giving any other format, you can also mention that format using SEP. So SEP is saying how your data is formatted from differentiated between the file. That's the reason it will be better if you show the file. Guys, there is nothing like showing the file is not an issue, guys, but you will not be able to look at the file and able to understand. It will be like cluster file in the Excel. Okay, you can just convert it to CSV. This text file can be converted. Yes, can be converted. You can just Google it, guys. Google any .csv file. You will find any sample file. You can download and check on your own. So that's not a difficult thing. Okay, let's move it. So CSV is not a difficult thing. You can download, Google it. What is CSV? Any CSV format file, and then you can check on your own. Okay, guys, let's move it. It's very simple, and you will be able to understand it. That's not difficult. Okay, so what I'm trying to do is I'm trying to read a data, whether it is from Google Drive or link or somewhere else. I'm trying to read and using the command pd.read.csv. So what I'm doing is whatever data I have read, I am stored it as an DF. Okay, data frame. Let's say DF. DF is a name which I have given to my table. Okay, simply try understanding this way. So DF is the name of the table from where I am saving this entire data. Okay, that's clear, I think. Once I save this data, next command what I will do is I will try to take a look at the top 5 records of my data. So for that purpose, what's the command? df.head, because I am looking at the top 5 rows. Okay, in this way. So this has given me a top 5 rows, returned me a top 5 rows. DF is data frame. Yes, ma'am. DF is data frame. Is genuine. So what we said is genuine or not. That's the problem we're trying to solve. So this is our target column, guys. Okay. This is our target column. This is what the result we are trying to predict, whether it is a true or false, is genuine or not genuine, true or false. Or you can give any name. For the simplicity they have given in genuine column, they're giving true or false values. Okay. So we already saw what are the features, all these 6 features and what they mean. So this entire data is numerical data, guys. Try and understand. Okay. This is a floating number because it is in the decimals digits. There are the decimal digits as well as the digits in the points. So it is not a whole number. So all these are floating numbers. That's how it will be get stored in the data. Okay, database in the table. And there, if you try to check the data types, it will give you what kind of data set it has. We'll go to it slowly. So what I have done is I have imported a file. Then I am trying to look at my data. Okay. Once I am trying to look at the data, I just simply executed a command df.head. It will return me top 5 records in my data, right? And as I told you, we are looking at these different features. So looking at the data, you can get a feel what kind of data is available on these columns. That's the sole purpose. So then we'll move ahead for the next thing. So we'll try to understand how many rows are there and how many columns are there. For that purpose, we are simply doing df.shape. So it will return me the value that there are 1500 rows and 7 columns. So obviously 6 features, all this from length to diagonal, and this is the final prediction what we are trying to achieve. Okay, df.shape. Once you are trying to see that what is df.shape, so we can understand easily that how many values I am expecting in all the columns. 1500 values, right? There should be 1500 values. If there are less values, then there may be certain values missing. So that could be one thing. Then we try to look at the different columns and the data type. For that purpose, what I will do, I will execute a command df.info. Okay, this will give me a column name. Along with the column name, guys, it will give me a count that how many elements are present in this column, how many data set is present, how many values are there in data set in this particular column, and are there any null values present, and it will give you also count for that null values. Okay, if there is present here, there is no null values, that's giving me 1500, because what is the shape of my data? 1500 rows. So for 1500 rows, there are no null columns, no null values provided in this particular respective columns. Okay, and it is also giving me a data type. So is genuine is a boolean. Why it is a boolean? Because it's a kind of a binary class. That means true false. We are giving here true false. So it is called as boolean value, whether it is a true or false. That's why it is taking as a boolean. If we have given certain other thing, whether it is a genuine or not genuine, it would have considered it as an object. Okay, categorical value. So that's how. So we have given true false. That's why it's considered as a boolean value. And like I told you, it is a floating numbers, not a whole number. They are providing something like 1.2 or something 1.3. All the decimals are also provided. Number after the decimals and all. So it is a float number, guys. Float 64. That's it. That's what we're trying to check. This is one more check, sanitization check, that we are trying to see what kind of data type I am expecting in what columns. Okay, feature columns, and how many values I am expecting. But for that purpose, I am doing df.info. Then moving ahead, try to understand how is the distribution. Okay, distribution of what we are trying to see here. So this particular target column is genuine column. We are trying to see how it is distributed, how many trues are there and how many false are there. That first thing we'll try to understand it. For that purpose, what I'm doing is I'm taking a value count. Okay, for this column df dot is genuine is our column. Then I'm taking value counts. Once I execute this command value count, it should be able to give me how much is the count. Now they have what they have done, rather than taking the count, they have said normalize equal to true. So it will return you the percentage. Rather than giving a simple count, it will return you the percentage. So it's saying 66% of the data is true and 33% data is false. So that's how it will give you a distribution of 100%. How much is the distribution of true? How much is the distribution of the false? That's what we're simply trying to understand. Because we should know whether it is a balanced class or not balanced class, right? Whether it is heavily influenced by true values or false values. If it is so, then we can take a decision that how we can upclass the things, upsample it. Means we're trying to make both the samples together. How we can do it? That's also different techniques, guys. But let's in short way try to understand that what we can do is we can create some duplicate values, pseudo values, and we can put it into the data set, which will be the values which are deciding whether this note is false or not. So we can create the samples for the false notes. So it will make a balanced class. Balanced class. So we'll try to add some samples. Let's say in this case, these are around 500 samples and these are 1000 samples. Just for the understanding, guys, I'm giving you this count, right? So we in total, how much values we have? Having 1500 values, right? If you could remember, I'll go back. 1500 values, right? We are having total 1500 values. Out of this 1500 values, around 500 values, okay, for the false, and around 1000 values are there for true. So we can say in this case 1500, yes. So what we can do is we can increase the count for false. So at least it will try to match up with it. We can do it, or we can do vice versa also. We can reduce the data, but reducing the data is not a genuine thing, guys, because more the data you give to a model, more scenarios it will be able to see, and it will give you a more accurate prediction. Simple. If greater data, better prediction. Okay, that's the rule. So why greater data, better prediction? Because it should be able to see different scenarios, try to analyze different patterns out of the data. For that purpose, if you feed it with a very good or large amount of data, obviously the accuracy will be high because it will be able to see all possible scenarios in the data. So that's one thing. For that purpose, we are trying to draw this graph. Okay, how much is the plot? And for that purpose, what we are doing, we are using cborn SNS dot count plot. Okay, guys, it's self-explanatory. So if you execute this command, and in this command, what we have to do is you can use this function count plot. In that count plot, you just provide the data, what kind of data frame you are using, and provide a variable. Here we are providing variable is genuine is the column. We are trying to look out of this data, and for that purpose, give me a count plot simply in this way. Okay. Let's move to next thing then. Once I am able to see how much is the count, guys, then what I can do is next is the histogram. So what they are trying to do achieve here is they're trying to look at the feature column, and they're trying to predict put a histogram out of it. I'll go through the code and I'll tell you what they're doing. So what they're doing, they're putting simply one loop, and in that loop they're saying figure and axis, and they're trying to call the figure and axis and how many plots we want, subplots, because it is not a one entire plot. They're using 6 different plots. Okay, for that purpose, they're calling PLT, that is matplotlib, and they're trying to tell it how much figures I am expecting. Okay, they're giving range like 12 rows and 4 columns. Up to that range, you can provide me the graphics. That's the simple tricks they're trying to do, and that they're calling the sns.histplot. Okay, that means histogram. Histogram is the plot which gives you a frequency count between the range. Okay, that is histogram. So it will giving you the different count for the different range. Let's say in here 103 to 103.25 to 103.50. What is the count? And it is trying to show you on the basis of the bar graph. Okay, that is histogram. So for that purpose, they're calling the cbon and histplot function. And that cbon histplot function, they are saying that okay, for axis, because axis you have to provide on y-axis what you are going to show, and on y-axis what values you will be take. For that purpose, they're saying on x-axis take values, on an axis just give the labels. For all of them, take the labels accordingly and then try to plot it. That's what they're trying to achieve here. And also hue is union, means hue means they're trying to also visualize using the target column, that how is the bifurcation in the column using the target. And for that purpose also there are certain other options is given, and they're giving title as distribution of data for all the columns, and then show plt.show title plt.show, call the hist plots for what all columns you are trying to pass, what the data frame you are going to use it, and that's it, guys. Once you provide this, it will try using the loop. It will take one column at a time, and then first let's say height from the left, and I try to create a histogram for it. Okay, then for the light height for the left with the distribution of the data with the is genuine or is not genuine. Okay, true false. Here we simply trying to look at data as a whole, and second part what they're doing is they're trying to bifurcate out of this height left how many are true or how many are false target column. That kind of bifurcation also they're trying to check over here. Okay, similarly we'll do for height right, and try to check how many true and false, try to visualize them for that particular column, then margin up and margin below bottom. Okay, clear, guys? So once we are able to bifurcate that, once you are able to see that, take a look at the all columns. Out of that columns, whatever target column, how many genuine, how many not genuine, that subdivision also I am trying to check here. Okay, that's, and it will tell me distribution of the data. Like right, take a look in this case. This is a histogram. When I try to join the center point for all these bars, it will create a curve like this. Okay, and using this curve, I can analyze. Okay, what we can analyze using this, whether this distribution is falling in normal distribution or not. Okay, here it will be the mean, and this is the right tail or left tail. If what we can see is whether my data is let's say my data is gathered towards the center or not. If I look at the center, there's a much more portion is towards the center, and there are less values towards the ends, and that means it's giving a cylindrical shape or this shape which is similar to a normal distribution. So I can say there is there is no issue with the data, and there are no outliers present. If there would have been outliers, it would have shown here or in the left tail or right tail. Left tail or right tail, there would have been certain values which would have seen, which are the outliers. So we can drop this outlier for that purpose. And how my distribution is data, whether they are away from the center or not, that's what we're trying to check over here. Okay, that's the sole purpose why we need a histogram. And also on the basis of the histogram, I can look it here. how is the bifurcation for the true and false. Okay. Out of the entire data set, how true and false are distributed as well. Okay. For that purpose also, we can look at the data and try to understand how is the sub bifurcation of true or false between the column height and height right. So how many values are true for height right? How many values are false note values? I hope this is clear, guys, that what we're trying to achieve is using the histogram. Once we are trying to achieve and understand whether there are outliers or not. So next step means I checked the NA values. We checked if there is any missing values or not, if there are any outliers or not using the graphical representation. Next step, what you will do is try to find out if there is any correlationship between the columns. For that purpose, what we are doing, we are calling the function correlationship, right? df dot correlation, which will give you a value of correlation between the column, and you are just passing this correlation function to the heat map graph, cbond dot heat map, and this correlation CoRR is nothing but df dot correlation, which will give you a correlation for entire data frame. Data frame consists of our entire columns and our correlationship between among them. That will be a table. This table will be presented. This table again passed to heat map, and that heat map will be given you a graphical representation along with the intensity of the color. Okay, along with the intensity of the color. When there is a high correlationship, that will be more brighter. When there will be a low correlationship among the column, that will be the lighter colors. Okay, dark and lighter colors. That's what heat map says. Okay, when there is a more concentration, the heat map will be of bright color, and where there is a less concentration, it will be of lower color. Okay, not brighter color, lighter colors. That's the thing we need to understand. Once I look at this graph, okay, I can see is genuine and the length column. Okay, it's genuine. This is the column is genuine, target column, and the length column. Okay, we are trying to look at the length of the node, right? This length. So, is there any relationship? We can see there is a strong relationship between the length because it's a 85.85 correlation. Correlation lies between 0 to 1, right? So there is a high correlation between these two columns. Likewise, you can try to understand what all columns are there and what is the relationship between them. Okay. So let's try and understand what else has a very strong correlation. Each genuine, okay, each genuine column and a margin low is also having a correlation of 0.78. Okay. So that means this feature is important. So whosoever are correlated with that, there will be two ways, guys, how we can analyze this. One is correlationship between the target column. What is our target column? Whether note is true or fake or not, genuine or not genuine, true, false. Okay, whether genuine or not genuine. So I am trying to see relationship between my target column and the feature columns. Okay, feature columns. Let's make it clear. Relationship between my target column and all the other feature columns. What will be the feature like length, diagonal, margin from bottom, above, okay, and height from the left and right. So this is the one relationship I am trying to check. Second relationship, what I will try to check the relationship amongst the columns. That means length, how it is correlated. Okay, how length is correlated with the height, how it is correlated with the margin, and how it is correlated with the diagonal. So that means correlationship among the columns and correlationship with the target column. That's the prediction column which we are trying to predict. Okay, true, false. Is genuine or not genuine, true or false. So this two type of correlationship we try to find out over here. So once I know the correlationship, which column has a correlationship, if the column which are having a very good correlationship with the target columns, those are the important columns. So I will keep those columns. I will not remove them because those columns will help me to predict whether this note is genuine or not genuine, true, false. They are making a significant contribution in my decision making. Then second step, why I'm checking the correlation among the variable is obviously to reduce it. I know if the two columns are having a strong relationship. Let's say length of the note and the height left has a strong correlationship. What I can do is I need not to take both the columns together. I can drop one of them and I can take only one. So this way we can reduce our dimensionality, guys. Out of 6 columns, we can reduce them Why we need to reduce? Because again, it is good that for computation purpose, because all the algorithm will performing the distance calculation, there will be multiple calculation will be done. If we are trying to reduce, if we can achieve the same goal and of accuracy with the less number of columns, it will be always better. So for that purpose, in order to choose a feature or reduce some dimensionality, we are checking this correlationship. Clear, guys? I think then we'll move to directly then importing the models. Guys, this case is very special use case, because in this use case, I'll try to see how the machine learning algorithm will fail if we don't do a good feature engineering. That is very good example how if I directly take all the columns and try to fit any machine learning model, it will fail. That is a good example we'll try to look here. So next step, I understood what is the correlation among the variables and among the target and the column. We also saw what is the distribution of the data between the column, how they are correlated with the target column. Are there any missing values or not? We can also check missing value separation. Okay, missing value separation is always we have checked where we saw not any values or any values. We can also do it. We can replace the any values if we find anything. Before that, what we do is when we trying to use any particular models, I told you that these models are already available in the packages, right? So in beginning, what we do is we imported the pandas, right? We imported the NumPy, then we imported matplotlib, and then we imported Seaborn. Why we imported them? In order to import them, import the data, perform manipulation, and then graphs. Accordingly, once I did with this data, once the data is ready, so I have to also apply the algorithm. For that purpose, sklearn is the library. Okay, guys, sklearn library has all the algorithms inside it. From the sklearn, you can call the different algorithms. For that purpose, you have to import the sklearn library. So first code, what we'll do is from sklearn model selection, we'll try to import cross validation prediction, and trend test split. Why we need these functions? Because cross validation, again told you, if I want to perform multiple validations on my data, for that purpose, this cross validation works. Like in this, say we saw one of the method like k-fold, okay, where we trying to fold the data, entire training data into different items, divide the data into different parts, and we are trying to achieve what we were trying to achieve is maybe this green part will keep it as a validation, and remaining part, this yellow part, 3 part, I will train the model. Next time, what I will do, I will just leave this green part now. I will come to this red part now, because first part was hidden first. Then I will try to hide a second part now out of the data, training data. And what I will do is I try to train again model on the remaining data. And in next iteration, what we'll do? Next iteration, I will hide the third part. In previous iteration, first part, then second part, then third part, and similarly, the fourth part will be hidden. Let's say if there are four folds we are using, and one by one, I try to hide them, one of the portion of the data, and remaining portion am I exposing it to the model, and then on hide whatever part we were hiding. On that purpose, we are trying to check the accuracy. That's the same thing we are trying to achieve using the cross validation. That is cross validation and cross validation prediction used for that purpose only. And trend test split, guys, I told you this function is used to split the entire data set into train and test. So the proportion can be 80-20 or 70-30. Could be anything depending on the situation, but usually we take 70-30 or 80-20. Okay. For that purpose, I am doing this sklearn model selection, cross validation predict, and trend test split. Okay. Then second thing here, we are trying to import from linear model, right? sklearn linear model, logistic regression, and linear regression. So you will ask, we are doing classification. Why need linear regression? In meanwhile, I'll tell you why they are using linear regression over here also. Then what they are doing is from sklearn neighbors, one more algorithm, k nearest neighbor, KNN classifier. Okay. K nearest neighbor classifier we are using. And then k-means. This is the clustering algorithm. There is also time to import and try to check with the k-mean also how we can implement k-mean hybrid approach. Then next thing, they are importing some performance accuracy checking criteria, that is mean absolute error, R square, and accuracy score. Clear, guys? This part of the code. So guys, just ping me, guys, that you are able to follow until now, whatever things we have done. So we can go ahead. Clear? Clear, guys? Couple of more words. Then I can understand what's happening here. Okay, okay. Okay. Clear? Okay. So we are saying yes, clear. Okay, guys, I think everyone is able to follow. So let's try to understand. Once what we did till now is we were able to import the data. We imported the first libraries. What all important libraries are there? Guys, am I audible or still it is breaking? Because usually I'm getting a couple of messages from the people that my voice is breaking. Is it breaking for everyone or is it clear, guys? Clear, clear, clear. Okay. Most of you are able to hear me. I think Anshika, we can check from your side. Maybe there is issue because some of them said it's very clear. Okay, it's very clear, guys. I can understand it's clear. So maybe you can check from your side. Sometimes it's breaking. Okay, okay, okay. Okay, maybe it is because I am just going away from my computer, laptop, maybe. But I'll try to speak very loudly, so you guys will be able to hear it correctly, everything very clearly. Okay, so let's try to summarize what all we did till now in the code walkthrough. What we did is we imported the libraries first, which we required for importing the data and performing the data cleansing. Okay, NumPy, Pandas, Seaborn. In second stage, we imported the data using read CSV. Okay, we imported the data. Once we imported the data, then we in third stage, what we do is we looked at the data like shape, try to describe the data, try to look at the null values. How many values are there? How many columns are there, right? How many values are there? How many columns are there? How many rows are there? What kind of data is there? What kind of data set is there? Whether it is a numerical values or text values or Boolean values, or it's a float value, right? We try to look at the data. Then what we did is we try to make the different graphs, right? Histogram, we saw. We also created some certain other graphs, right? Looking at the graph, and then in the end, we were able to plot the heat map of the correlation plot. And using it, we were able to analyze that what correlationship exists. Two types of correlation. One correlation with the target column, one correlation for the features among all the columns. And using that, we were able to identify, okay, what will be the important columns, which will help me to make the decision. And accordingly, I will be able to take the decision. Once I am through with it, then what I did is I am going to import the libraries, important libraries which are available in the sklearn. Sklearn is the important library in which sklearn I have all the algorithms which are required for the classification, regression, or clustering purpose. That's the simple thing I'm trying to over here. And also we also have a function which will be used to calculate the performance of our model. For that purpose, mean absolute error, R score, accuracy score, cross validation for creating the different split of the data set, and trend test split for how to convert our entire data set into trend and test, and then feeding it to the algorithm. Till now, we have achieved these many things. Now we have imported the algorithm. Now let's go and do some manipulation also if we have any values. Or let's do a trend test split. Here they are separating the trend and test split data. So first train data I have to create. So they are saying margin low dot not NA values and copy. So this is one way also, guys. Excluding NA value, just copy the things, and margin low, just is NA present, then don't take that value and create the value. Or you can replace NA values also anyway. Okay. Then trying to take what they're trying to do is create a X train and Y train. What is X train, Y train? Again, I'll tell you what is X train and Y train they are trying to achieve. X will be all your feature columns and Y will be your target column. In this case, what is your target column, guys? Target means where I am trying to be genuine or not. Whether the note is genuine or not. For that purpose, I am seeing whether it is a true or false. So that will be called as Y for my machine. Okay. And for X, I will have all my features, 6 features which I looked at: length, diagonal, margin, okay, and height. So that will be called as X and Y. That kind of bifurcation I am going to do. So my model can understand this is the value. Okay. This is the value I am trying to predict on basis of these features. So for that purpose also, we need to create X train, Y train, X test and Y test. That's the simple thing they are trying to do here. Okay. Then moving ahead. So first what they have done is they created a model for the linear regression. Okay. I'll tell you why they are using linear regression here and everything. Meanwhile, once we go through this, and what they're doing is they're trying to fit this data, okay, cross validation using the cross validation. Why text is commented? Where it is commented? Okay, why test is commented? Okay, why test is just for the understanding purpose. They have done that. Later on, they will take again Y test and X test. Okay, as of now, they're taking the X test. That's what they're doing. We can also take Y test and later stage. Then we can create a Y test, X test, or Y test, X test. Then we can feed it to the machine. Okay, machine learning. Okay, so what we're doing is usually first we are going for the linear regression model. Model equal to linear regression. We are passing it to cross validation predict model X train, Y train. Cross validation 10 folds we are taking here, and jobs is how many times you have performed parallelly, how many jobs you have to perform. That kind of parameter is there. Okay, this parameter is just telling you that how many jobs you have to perform. That is parameter. That's not an important parameter. You can later on check on it. For CV, I told you like how many folds or how many iterations you have to do for this training data, cross validation data, and then providing what is train data, what is target, what is column, and model equal to linear regression. That's what we are trying to pass it to it. And then we try to calculate the mean absolute percentage error by performing the prediction. And then we are taking the R score, the mean absolute error for validation data and the R score data. So they are able to see that R score data is 0.40, right? And the validation score error is 0.08, okay, which is not acceptable, right? R score is really very low. We'll try to understand in detail as we go ahead. We'll try to understand what is happening here because our scores is very less. If I try to fit the linear regression and try to check the accuracy, R score is the way how we can analyze the performance. So it is giving only 46%. It should be on the higher side between 0 to 1. This value lies, it should be on higher side, and also it's giving me an error that error is only 0.8%. Okay. So even though but my R score is not good, I cannot take this model. So we'll try to understand how linear regression is playing part because we are doing a correlation here. CV is cross validation, guys. Okay, cross validation. I told you the method for using which we are creating a different sample sizes and try to create the validation data set. For that purpose, we are doing it. What is R score? R score is again a measure how we can check the performance. Okay, I understand this way only at this moment. R score is the measure to check the performance of the linear regression. It should be between 0 to 1. More higher the value, better is the model. That's it. So what we're doing is why sole purpose why we are doing taking this thing is let's understand when we look at the visualization. Number of jobs, guys, don't forget it for the moment. This is just the advanced parameter which they are giving that how many parallel processes they have to do when you are performing this iteration. For that purpose, they are taking it. But at this moment, it's not necessary to understand. Just try and understand our visual code. It's a very advanced parameter they are giving. So what they are doing is they're taking the mean values. Okay, mean value for train and mean value for prediction. Max value out of this train values and max value of the prediction, and on the basis of mean and max, they're trying to put a plot. Okay. They try to put a plot and trying to visualize their prediction. What is the mean value, what is the max value, and whether on the basis of this prediction, results they are trying to copy and trying to create a scatter plot out of it, where x equal to margin low equal to prediction and this, and this line plot they are trying to do this. So I told you that this whenever they're trying to fit this model, it is not accurate because it is giving you error is less, but it is giving very low score, right? They're trying to whatever model they built here, okay, whatever regression model they built, okay, this was only giving me 46% of R score and 8% of the error. That same model by using this min max values and then trying to plot this scatter plot, taking the results, okay, result equal to y predicted value against the actual value. Okay, mean max value they're trying to achieve. They're trying to highlight what is the mean value, what is the max prediction, and they're also taking the prediction and trying to plot it. Simply understand in this way, guys. Okay, scatter plot they're using and line plot they're using to show the regression line, how it is fitting to the data. That's what they're trying to achieve. Very nice. Okay, thank you, guys. Let's move ahead and try to understand what we're trying to do here. Okay, so what I am trying to do, whatever prediction I have done, I am trying to plot the prediction against the actual data. Okay, train data and plot data. And out of that, what are my max values and mean values and how my regression model is fitting. Because I told you in regression, what we are doing, we are taking our x values, y values, and these are my values spread across, right? So in regression, what we do usually, we try to understand, we try to pass a best fit line out of this data. And the basis of this best fit line, I am trying to predict the values. Let's take different color for predictions. This prediction will be the points which are on my this best fit line, okay, which I have fitted here, and the actual values will be this, and this will be the error which I am trying to measure here. So that's the purpose, whole purpose this regression model does. They're trying to visualize this thing. That's why they're taken a scatter plot on the base. This scatter plot will giving you the values of the actual and predictions, right? For low margin, what is the Y prediction they are trying to check. And on the basis of that, they are trying to say whether my model is able to fit a best fit line or not. For that purpose, they are trying to check it. But if you look at these things, regression model, they can easily say that it doesn't look good because it's not trying to calculate the maximum point, right? And then, though it's giving very less error, but the R score is, I already told you, the R score is very less, guys. That means only, let's say, try to simply understand in this way that it is giving me only 46% of accuracy. You can put it in there. It doesn't mean that only 46% accuracy. What R score means is, actual meaning of the R score is that only 46% of the variance, only 46% of the variance. What do you mean by variance? I will tell you again. What R score denotes it. Let's say these are my data points. And then I'll try to draw them. I'm trying to fit a base fit line. Okay. On the basis of that. So this regression line is my prediction size. Clear? This line which I'm creating is my regression line, which is my prediction, and this is my actual point. There is a difference between, right? This distance is there. This distance is called as variance. Okay, variance means how my actual prediction is varying from the real data. So that is called as variance, and variance will be calculated for all the summation of the variance. I will do a summation of the variance, and that variance combined score will be given by the R score. That out of 100% of variance, how much variance was explained by the model, my model. So my model should have explained even 100%, up to 100% or 99% or 98%. If it is able to understand the variance, give me explanation of the variance, then this base fit light would have gone through this like this, and there would have been a very less distance between actual and prediction. Okay, I understand it this way. So even instead of giving 100% prediction, it is only give a variance. It is only try to explain 46%. That's why this model is not acceptable, guys. This part is clear. What is variance? Why it is not acceptable? Regression R square gives us a variance. How much variance is explained by our model? So it is able to explain the entire higher side of the variance. Sorry. So that means my model is performing very good and I am very close to the reality. What is the difference between reality and my prediction? That is variance, and that's what we are trying to measure over here. That how your model is trying to measure variance, whether it is able to give a correct variance or less variance. If it is able to give you only 46% of variance, that means your model is not performing good. That is what the meaning of the R score is there for the regression. Attendings will be given, guys. There's still time. Okay. We try to understand, go through the code. Okay. We'll be finishing fast, then maybe we try to understand. I think you guys are aware now. What we did is we fitted a regression model. We made some prediction, and we tried to saw how my best fit line is going through the data. Visually, we try to analyze the prediction. So, but it is giving me a very less R score, so I cannot go with this model. That's what they simply trying to tell you. Okay, so guys. So let's try and understand then what we're trying to do here. Guys, what is the thing that we are trying to convey over here is, in this case, what we did is we simply took all the columns which are available, right, in our data set. Let's go to columns. Whatever columns, 6 columns were available, right? Whatever 6 columns were available, we simply take all the 6 columns and we try to make an experiment that let's fit one algorithm on it and try to understand whether this algorithm will be able to predict the things correctly or not. And it failed. Okay, it gave only 46% of accuracy. So that's the reason we're trying to take a raw columns without performing any transformation on the column, and we try to saw how it is performing. So we saw that there are many areas where we can improve on it. So for that purpose, what we can do is, are we going to do a feature transformation? Very important thing, guys, feature transformation. So with existing feature, whatever 6 features are given, okay, 6 feature, what is length, margin, diagonal, margin from top or bottom, and height from left and right. With that, my model failed to give me a accuracy, whether it is a genuine note or not, real or note or not. So for that purpose, guys, I just cannot go ahead with this column as in current conditions. So what I can do? Can you guys suggest that what could we do if my current whatever data structure is present, whatever columns are not present? I just try to simply fit in a model, and my model is not, even though error is less, but the model performance is not that good. Okay. So what could be the situation, or what could be the solution for that this situation? How we can improve upon? Any suggestions, guys? How we can improve this one? What could be done? Because we cannot change data, right? Data is there. These are the columns, and with these columns only we have to go and make the prediction. So what could be the way through which we can improve this situation? Any suggestions, guys? What you can think? What we can do? Anything related to data transformations? Once more, my question. Okay. Clear, guys, what I'm trying to tell you, that with the current columns which are available, like diagonal height, left, height, right, margin, and length, I try and take the column. I saw that if there are no missing values or no outliers are there, data is there, I cleaned it. I did everything. I took even correlationship among the data. And then on the basis of that, I am trying to fit a model, but my model is not working, guys. It's not only working with a 50% accuracy. So what we can do now in this situation, because I cannot change data. This is the only data available with me. So what could be the situation through which we can improve our algorithm? Use other algorithm. Yeah, could be possible. What else we can do? What kind of transformation we can do with our data? Any transformation possible? Normalization, correct. We can do a normalization with the data. Could be one possibility. Any other things? Any other things, guys? You can come up with what we can do. Upsampling is also possible, right? Convert target columns. Yeah, that will be done. Otherwise, how we will be able to predict? That will be taken care whenever we're trying to pass it, we'll do it. Standard scaling, correct. We can do a standard scaling. These are certain ways we can do it. What else we can do? What we can do? One hot encoding has to be done, ma'am. Yes. It has to be done, otherwise we will not be able to fit this model. Correct. One hot print coding is there. Systematic analysis. Yes. Analysis of strip on the notes as a new column. Yeah, you are close, Shiv Prasad, but not a new column entirely. We are trying to introduce, because whatever limitations we have is we have only these many columns available. So we have to come up with something out of this available data only. Clause validation is okay, but what we can do with the columns? Feature extraction. Yes, feature extraction. Let me tell you without wasting time, because we already have to cover some topic. So what we can do is, guys, in this case, even it is good. It's a good idea that we can scale this data. Okay, we can normalize the data. We can use a z-score, or we can even use log. Yes, we can use multicollinearity, which we checked already, right? When multicollinearity is what? Is there any relationship between among the columns? So why we did this correlation plot? To check the multicollinearity only. So we did not find any multicollinearity. That's why we were entered with the columns, right? What we can do is, we can create new column by merging certain other column. So what they did is, they merged margin up and margin low into one and called it as a margin total. Okay. And they created another column which is called as margin difference by making the difference out of the bottom margin and up margin, and they try to introduce them. Okay, this is called as feature extraction, or you can say feature engineering. So out of present column, maybe we try to merge the columns and try to create a new column out of them. And let's try to understand, because this is a really use case, good use case, guys, because you need to understand. Use RFP to drop the columns. Yeah, it's possible RFP, but what we can do is we can also create new column by merging. This could be also one way, intelligent way. Because we drop certain columns, it is possibility that we may lose the information which is available in the data set, because we see that there is a importance of the columns for the prediction. If we create a new columns, means the data structure may be extracted based on the requirements of the parameter. No. Maybe it's data structure. We're not trying to extract the data structure. What we're trying to do is, out of two columns, I'm creating entirely a new column. That's what I'm trying to do. We have a separate column, margin up and margin bottom, right, on the node. So instead of using them, I'm trying to create a new column using them only. So I'm taking the difference. First, I'm adding the margin, and then I'm subtracting the margin and trying to provide a new column like total margin and margin difference. Yes, that's what trying to do. We are trying to merge the column. That's why creating a new column. Margin total and margin difference. And we are trying to plot this margin total histogram. So in order to understand how our new column is looking like. Margin total is what? Margin from above and below. We are trying to add it up, and we're trying to create a new column, and we're trying to plot a histogram out of it, and then we'll be able to see whether this histogram is fitting or not. Kind of resampling. No, resampling means we trying to increase the data points in our data. It's not, we are not increasing any data points, guys. We had 1500 values, right, in our data set. We are keeping all those 1500 values only. But what I am trying to do is, rather than taking separate margin bottom and margin top, I am just calculating difference of this, that is calling as margin difference, and I am adding this and calling as a total margin. And this kind of two columns I am trying to introduce, but I am giving all the number of data points same, 1500 only. Okay, that's what I am trying to do here. That is called as feature engineering. We're trying to merge certain columns and create a new column among it, and we're trying to visualize how the distribution is looking. So when I look at the distribution, somewhat it is fitting to the normal distribution. We can go ahead with this one then. Then similarly, we saw the margin total. Similarly, we try to analyze the margin difference. Okay. No, we already, it's not about correlation. Correlation we checked at the initial stage, right? But somehow our model is not performing, right? For that purpose, I have to tweak my data, and for that purpose, what I'm doing is merging the columns. So I'm totally changing the entire meaning of the column, right? How not entirely, but I'm trying to bring new data using the addition of the margins. Once I am adding the margin, bottom and top, and I am subtracting the margin. So I'm calling as a total margin and margin difference margin. And then I'm trying to visualize. Okay. So let's say if work, it can be experiments, guys, different experiments you have to perform according to the situation. And then when I'm trying to do this experiment, let's say they have done this experiment, you can do any other experiments also. And on the basis of the experiment, try and understand what is happening. Because in the end, guys, you have to do the hyperparameter tuning. It is kind of hyper, let's say feature engineering, not hyperparameter tuning. We can call it as a feature engineering. So we're trying to understand again how this is behaving, margin difference. Again, it's somewhat coming to the normal distribution maybe, but it is somewhat negatively, say, peaked in the left direction, but it's okay. We can at least go ahead for this one iteration and try to check the accuracy. If we are getting a good accuracy, then maybe we can go ahead with it. Okay, so let's quickly then go ahead. We try to imagine the things using the histogram. Okay, and then we also splitted our data XY, like is genuine or not. And then we try to fit a logistic regression over here with the clause validation. So what we simply did is, rather than taking the column like that, we created two new columns. One is total margin, and the margin difference. And on the basis of that new data set, now we are trying to fit a model. Okay. So now I am calling a logistic regression. And for that logistic regression also, I am passing a cross validation, like iteration, not a single iteration of the logistic model. I am taking the iteration, 10 iterations. For that 10 iteration, it will create a 10 times logistic. For 10 iteration, it will create a 10 logistic regression models. It will try to check with a different combination, and then it will give us an accuracy. That's what cross validation says. We are passing a model as logistic regression. We created X as our feature, Y as our target column, and then we are passing it and then trying to check the accuracy. Now, if you check the accuracy, guys, it's amazing, right? It has right from 49, somewhere 49%. It has directly jumped by, right? Jumped by 40%, right? Or 50%, right? 40, more than 40%, it has jumped 50%. So it directly giving me 99% accuracy. See how amazing a feature engineering can work, right? So if you try to tweak your data, because previously what we did is we took a raw data and try to make a prediction just by doing the amputation and cleaning of the NA values or duplicate values or outlier values. It was not able to perform at all. It was only giving me certain around 46 to 49% of accuracy. But when I tweaked my data somewhat, I merged my columns and created a new column. And then when I'm passing it to the logistic regression, it worked amazingly. It gave 99% of accuracy, guys. That means what? With 99% accuracy, we can say whether this note is fake or true. So this is performing very robust prediction. So guys, understand this kind of feature engineering. Why I was saying this is really amazing use case, because people usually what they do. Yes, guys, if your model is performing very well, accuracy is high, means what? With 99 times out of 100 times, 99 times, it will be able to give me correctly whether this note is real or fake. That's how you can analyze this. Out of 100 times, 99 times, it will tell me correctly. That's the model accuracy, guys, for logistic regression. See? So main motto why we did this exercise is, we also saw yesterday all these steps, but the only difference what we did here is we try to tweak the features, and then out of these features we create a new feature, right? And for that purpose, if once we do this transformation, there is a huge jump in our accuracy. So guys, this is also one of the trick how feature engineering works. If you use previous raw data to logistic regression, what will happen? Okay, nothing will happen, guys. Try to check, try to do it on your own. So most probably it will not give us this kind of great accuracy. Maybe it will give a less accuracy. That's will only happen. Okay. So what we are trying to achieve is, we are trying to achieve a very robust model. That's the purpose here, entire purpose. For that purpose only, we are trying to tweak the features. Okay. So confusion matrix, guys, again, is one of the metrics where we can understand the performance of our classification models. So this model gives us like this one, reality. From where we should download PDF notes. So guys, it will be available in the LMS, okay? In learning management system, it will be available, okay? And from that, guys, quickly let me just finish the last topic so we can have a discussion or question answer. Okay, we're running late out of time. So let's understand what is confusion matrix. Let's say this is reality, okay, and this is our model. Okay, whatever our model is saying, this is our model performance. Okay. So in reality, let's say it is 1 or 0, and our model is giving whether it is a 1 or 0. So that's how whether our model is able to predict it correctly or not. That's what we are trying to achieve looking at this confusion matrix. So it said true positive, false positive. I will explain, guys. Don't worry. First, let me create a table. And then this is false negative, and this is true negative. Okay, true positive, true negative. This means what? If in reality it was 1, and my model was also able to see that it is 1. So that is called as true positive. Means whatever number was positive, my model was able to identify it correctly as a true positive. Is there any test for this FDP? What do you mean by FDP, sir? Madhuri ma'am, FDP? Let me just elaborate so I can answer it. Okay. If in reality it is number 1, and my model is saying also it is number 1, that means true positive. So it was actually positive, and my model was able to also see it is positive. But what happens is in reality, if let's say it is 0, that is negative, but my model is saying it is positive, that is called as false positive. Vice versa, if my in reality, if it is negative, but my model is saying that it is it is also negative. Model is also saying negative, reality is also negative, true negative. If my model is saying negative, but it is actually positive, it is false positive. This way, we can classify result of our classification model. On the basis of that, we can calculate recall, precision. Okay, these are some measures we can discuss later on. And the accuracy. Accuracy will not be the accuracy, but the F1 score. Okay, what will be the recall? That out of reality, how many true were predicted? Let's say there were 100. In reality, there were, let me clarify it. In reality, there were 100 positive values in the data set. And out of that, my model was able to tell me, okay, 80% of the values are positive. That means my recall will be 80. Okay. Similarly, we can calculate precision and all. Just to give you guys what is true positive, false positive. It was the exercise. Okay. And depending on the use case, like I told you, if it is a medical use case where I require highest accuracy, precision is important, right? And when not that much accuracy is important, then maybe recall is okay, because in recall they are also giving us a false positive along with the true positive, right? So it depends on how you want to increase, whether you want all true positives to increase or whether you want mix of false positive, true positive. On the basis of that, you can choose these matrices and analyze the classification algorithm. That's how it guys. Okay. So you can see this precision, recall, everything will be given, calculated. If you try to print a classification report and pass on the actual Y and prediction, so it will give you precision, how much is the precision, how much is the recall, how much is the F1 score. F1 score, again, why we are taking F1 score is again a different class altogether, but I will tell you quickly that if there is a more F1 score, that means my model is giving me a correct accuracy, because in simply in classification, we cannot go with normal accuracy. For that purpose, we need a different criteria. That's why it is called as F1 score. F1 score formula is 2 into recall into precision divided by recall plus precision. This is a different technique, and there is some intuition why normal accuracy will not work. For that purpose, they have created a new performance evaluation criteria called as F1 score, and they're trying to calculate the recall precision, and on the basis of the harmonic mean, they're taking harmonic mean and the formula coming to 2 into recall into precision divided by recall plus precision. They're calculating the F1 score. F1 score will be able to tell us clearly that how my classification model is performing. Okay, how accurate it is giving you the scores. Clear, guys, till now? So similarly, what they did is they also implemented the k nearest neighbor. There is nothing else with all the different values of the k. So in k nearest neighbor, what we are doing, we are taking the values of the k. Okay, different values of the k. On the basis of that, they imported this cross validation also, and then k nearest neighbor classifier. We saw previously logistic regression. Now they are going for the k nearest neighbor. Quickly same thing. Import the function. Try to take the different values of the k, and then try to fit in a model and try to check the accuracy using the classification. Okay, check the accuracy using the cross validation. Okay, with all precision and recall, and F1 gives same value. How we interpret the accuracy? No, guys, it's not same accuracy value. I will tell you there is a different use case altogether. Just try to understand the F1 score is very important. If F1 score is high, then our model is performing well. We cannot go with the accuracy directly for the classification models. Recall and precision, I will tell you according to the situation. For some situation, we need high recall. For some situation, we need a high precision. Let's say high recall or precision. I will quickly give you example like if there is a COVID positive test, and then at that time will require a high recall, because even if you say in COVID, if you find positive, no issues, you can take medicine, still you will be saved. Even though the true positive and false positive numbers is more, then it's okay, but it will not harm you critically. It's like a very dangerous calamity or something else, very danger error, or let's say very harsh error. Okay, but if you say you are taking a court example of the court case, even if you are not guilty, if you are proved guilty, then what will be right? Very harsh implication, right? It will destroy a person's life. At that time, we require more precision. So at this kind of situations, we need to understand what kind of performance criteria I need, and accordingly, I can put it to the situation and I can use the recall and precision. Then F1 score is like looking at the both the situation, recall and precision, and try to take a balance out of it. And that's why we go for the F1 score. In F1 score, we try to understand all the recall precision values and then trying to combine these values and try to find out at least if my model is giving highest F1 score, at least it is performing better on both the situation. That's how simply, guys, try to understand this way. Clear, guys? Any doubt? So, okay, what they did is also along with the logistic regression, taking the different neighbor values, they fit in the k nearest neighbor, and then we try to check the accuracy, how they're giving. So if you take the accuracy, also giving it 99% accuracy. Procedure is same, guys. They're just calling the k nearest neighbor, passing the values, and then try to fit a model and check the accuracy score. Prediction, actual versus predicted, and then it will give you accuracy score. There's a function called as accuracy score. You have to pass the actual value and predicted value, and you have to fit the model, like model equal to k nearest neighbor. You fit a model, k nearest neighbor, okay? In this way, k nearest classifier, and tell that how many neighbors, tell how many neighbors you want, k nearest neighbor classifier, predict on the basis of the model, and then check the accuracy. Only 3 lines of code, guys. That's it, and model is done. Okay, this is simple, right? So just call the model, pass the prediction values like model and values x and y, and check the accuracy score. That's it. Model is done, and it's giving you 99% accuracy. It's again up to the logistic regression, same thing. So we can choose any of them. Okay. Same again, they're trying to print the classification report and trying to check how is the true positive values, false positive. In this case, if you see, okay, classification score, the true positives are more and false positives are less. That means recall is high, right? Also, false negatives is less, only 4 values are false negative, and true negative is high. That means this model is performing very good, because for negatives, it is giving negatives 996 times out of 100, let's say. Out of 100, it was able to identify all correct negative values, 996 values. Only 4 values it failed. And for recall also, whatever positive values were there, 491 positive values were correctly identified by the model. Only 9 times it failed. So if I look this bifurcation confusion matrix, It's also give me hint that how my model is performing. So it is giving a robust prediction, guys. That's it, guys. Any confusion? Or are we clear? I think attendance is already shared by Amar. Just ping me, guys, if this is clear or this is amazing, how we took the feature, how we took the everything, because you guys will have to perform one use case like prediction for the customer churn. Similar code, similar, everything will be similar, only data will be different. It will be bank customers data having different columns. So, and end goal will be like to predict whether the customer will churn or will not churn. Okay. In next class, I think it is self-explanatory that there will be columns. Okay, different columns for the bank customer like age, income, whether he is having any account with you guys or not, and certain other criteria. On the basis of that, you have to predict that whether this customer is going to leave you or whether he is going to stay with the bank, whether he will leave or whether he will stay as a customer with the bank. So these two classes you have to identify based on the data. So most probably what you'll do, you'll try to fit a classification model and try to understand. Simple use case, guys. And even though it is a very simple, but it has a very high importance, because looking at it, company or any bank can decide how they can retain their customers and increase their business. Clear, guys? So data will be provided in the LMS, I think, and Amar will be giving it to the backend team. They will make you available. So should we choose regression or classification? Classification, guys, because what we're trying to do is we're trying to classify whether the customer leaves or customer stays with us. Customer stays with us. Only two categories we are trying to look: customer staying, okay, or whether customer is leaving us. Two categories only we are trying to predict out of this data. Amazing session explanation. Thank you very much, guys. Just put in some more comments that what you feel about today's session and whether you are good with this. But regression is also giving F1 99. No, regression was not giving F1 99, guys. Regression will not have F1 score. F1 is different for that purpose. Just put in some comment, guys. If you are clear with the use case, data will be provided. CSV data will be provided by Amar and backend team for you guys, and you have to fit and check the same this all the sleep order detection and this one fake node detection. All these PDFs will be available. You can use the same code. You try to implement the same code, but the data set will be different. The use case is different. All the techniques or the codes have to be same. Just try to come up with the different data. That's why for the practice purpose, I have given you. This is the real implementation in the real use case for the banks. So this is a good model. If you are able to fit this model, then you are a data scientist then, guys. Clear, guys? Not deep learning concept, guys, but this project concept, I think. The heading, just ignore the heading. Deep learning will start from the next week. Slides are not available, but it will be made available today by Amar and backend team, guys. Don't worry. Just vote it, guys. Vote it. Vote your opinions. Whether this was clear, you were able to follow everything. Amar has launched the vote poll. Just vote it, guys, quickly. So you'll be able to get a good feedback from you guys, so we can proceed accordingly then. Come on, guys, quickly. Just vote it. Vote whether you guys were able to follow everything or not. Slides will be made available, or CSV data, PDFs, everything will be made available. It will be in LMS, guys. From LMS, you can follow these things. You can take it from there. Now it is not showing. LMS is not showing. Okay. Yes, but it will be made available. It is already given to the backend team. Most probably by evening they will make it available. Before even night, I think. Any other thoughts, guys? Please don't forget to vote it. Attendance link is already shared by Amar. Please mark your attendance, guys. Please vote. Please tell us that whether you are able to follow this one or not. It's very important because end of this you will become data scientist once you are able to follow and solve this use case. Guys, only 120 people have done voting as of now, and there are more like around 400 people present. Please vote. Yes, we got logistics with 99%, correct. Please vote, guys. It will be giving us a real feedback, like whether you guys were able to understand it or not. They have taken so much effort, at least why don't you give us a good feedback, right? If you're able to understand. 400 people, at least I'm expecting 300 votes, guys. It's only 150 as of now. Before leave, please vote. Yeah, please vote also along with your comments, guys. Few more votes, guys. Only 150 people have replied to this poll. Please fill this poll. Please give your feedback. Don't forget to give your feedback, guys. Come on, we're done with the session. It's Friday. We need to enjoy our weekend. Come on, quickly, so we can end the session, guys. It's already time to end. Harmonic mean we can understand in later lectures, guys. Just try to understand this is the formula they are using it. Why less votes, guys? Friday. I know you are eager to leave, but at least give us a feedback so we can understand and improve accordingly. If you are able to follow, then why not to vote, right? All these things, all these pains we are taking just for your understanding, guys. If you're not able to understand, what's the use? And whether your guys are able to understand or not, please provide your feedback. Then only we can understand whether your guys are going it for not. Are you on the same page or not? And don't forget to mark your attendance, guys, right?
Yes, sir. Tomorrow there is no session. Huh? Our next session, day 6 on Monday. Directly.
Yeah, guys, we'll directly meet on Monday. Weekends, we're giving off. We'll see you. We'll directly start with deep learning, guys. Very interesting topics to come in. We'll try to create our own neural networks. We'll try to see how computer vision is solving problems. We'll work with images, everything. Very interesting topic to come. We'll also try to build a chatbots and everything. So don't forget to join next week also. And please, guys, try to express yourself. Let it be vote or chat. Please give your response, at least so we can understand and plan accordingly then. All this pain and all these efforts taken by the principal sir, all the colleges is for your understanding only, guys. So please do give your response, feedbacks, and try to make it a genuine effort so you guys are able to understand and get really good insights. So you guys will become a successful data scientist. End of this session. Come on, guys. Quickly. It will take only less than 1 minute to poll, to give your opinion. Whosoever done with the poll and everything, guys, you can leave. And who wants to poll or mark attendance, they can even stay back for a moment. And then we'll try to end this session within 2 minutes. Okay, guys, we can conclude now within 2 minutes. No new topic will be covered. Attendance is already given. Let's move ahead, and then I wish you guys a good weekend ahead and see you next week then. Okay. Happy weekend, guys, then. See you next week.